In this lesson, I am going to describe about lattice energy for potassium chloride and how to derive the Born-Haber cycle, and using that how to calculate the standard enthalpy for lattice energy. We first consider the definition for potassium chloride involving lattice energy. We have to use potassium ion and chloride ion. The important thing is these should be in gaseous form, and then it will form solid potassium chloride. Then we have to look how do we obtain gaseous ion for potassium. So we have to go potassium atom. Also for chlorine, we have to go chlorine atom. Then we will look what is the process that should involve for this conversion. From going potassium atom to potassium ion means it involves ionization. Then I will write delta H IE, this means standard. This one, we have to add 1 electron to convert chlorine atom to chloride ion. Then it will involve electron affinity. So this side is complete. Then we have to look how do we obtain potassium. These are not stable in normal condition. So we have to go the stable form of potassium is solid potassium, and stable form of chlorine is gaseous chlorine molecule. Then we can balance this chlorine by putting half. Now we can see solid potassium should go to gaseous potassium. It involves sublimation. Right? Delta H sub, that is for potassium. And chlorine, there are 2 atoms in 1 chlorine molecule. Then we have to break the chlorine molecule. That means delta H bond dissociation flow chlorine molecule. When solid potassium and gaseous chlorine react also, it can form solid potassium chloride. Now this is the normal reaction we are familiar with. This should involve delta H enthalpy for formation of potassium chloride. Now I think you have a good idea about how to build up this Born-Haber cycle for a particular type of ionic compound. Then we have to write here delta H Le, and again remember the definition for lattice energy involves gaseous ion and solid ionic compound. The solid ionic compound should form from the relevant gaseous cation and anion. Now I am going to apply the Hess law. The formation of potassium chloride, its enthalpy should be equal to the total of these enthalpy values. This is one path and this is another path. So I am going to write formation of potassium chloride. That is the enthalpy of potassium chloride for formation should be equal to these 2 values. Sublimation, that is for potassium, and bond dissociation, that is for chlorine. First ionization energy of potassium and electron affinity of chlorine plus lattice energy for KC. Then I can rearrange the equation, so we can directly substitute the values to find out the lattice energy. Now this is the final answer. I have substituted all the values for this expression. Then I got minus 717 kilojoule per mole. Now I am going to recalculate the same problem by using a different method. This is energy level diagram. The first step here you have to consider is determine where the 0 points should be. To determine that, you can add all the negative values and positive values in that table separately. Once that I got positive value as 751, negative value as minus 786. That means they are nearly equal. Then I can keep the 0 point roughly in the middle. The unit is kilojoule per mole. It is important when you manage the space you have. Then you have to think what are the elements you are going to place in the 0 level. Thermodynamically, most stable elements here solid potassium and molecular chlorine should be placed in the 0th level. We can also put half here. Now let us look the values. The enthalpy of sublimation for solid potassium is 89 and enthalpy of dissociation for chlorine is 244 and enthalpy of ionization for potassium is 480. So ionization has the largest value, so it should be placed in this level. Before go to the ionization, we have to convert potassium to gaseous potassium. So I used this table, gaseous potassium and 89. That energy should not be go to the chlorine. Then we should not change chlorine. Chlorine should be placed at chlorine gas. For chlorine, I use this level. Potassium should not change. Then chlorine should be 1 gaseous chlorine atom. Then this energy gap would be equal to bond dissociation energy for chlorine 122. These are in kilojoules per mole. Then I can add this 122 to 89. It is 240. It is 211. Then I can go to the ionization of potassium. Right here. It requires 418 first ionization of potassium. Then I had to add 211 to 480. Then this would be 629. We have to apply electron affinity or electron gain enthalpy flow for chlorine. It is 349. We have to come from this level. So this is 418 and it should not overcome that gap. I will choose this level. Chlorine became chloride and potassium should not change. It's the solid potassium chloride. It forms from solid potassium and gaseous chlorine. Standard enthalpy of formation for potassium chloride. Now here, then we have to look what is the lattice energy. Lattice energy, as mentioned earlier, it should involve with the formation of solid compound from the relevant gaseous cation and anion. Here we can see potassium and chloride ions are there. Then we can directly take an this should be equal to the lattice same. So if you carefully use these gaps and apply values, then it won't be difficult to calculate the values. Here, this gap should be equal to 437. When we consider the gap, we don't consider whether it is plus or minus. Then we have to find this gap. Let us say that is delta is 1. To find that gap, we have to consider this total gap from here to here and subtract this small gap. That small gap will be equal to electron affinity value of chlorine. That value should be equal to minus 349. And you can see the total gap is equal 629. And I can subtract this value from this. So this would be equal to 280. Once we add this 280 and 437, it is equal to 770. Now we can determine the sign of this value. Here we have to come from up to down. The arrowhead should be like this. From up to down means this should be negative.